So a lot of times we have expressions that can look really complex and we need to simplify them, right? So we've already done problems that are like this, where we have, maybe 3x to the 7th over 9x to the 4th. Okay? So the idea when we're doing these ones is we want to break these into smaller parts. So that's 3, and x to the 7th means I have 7 x's, right? So 1, 2, 3, 4, 5, 6, 7. And 9 is really just 3 times 3. X to the 4th is like this. So when we broke up all the pieces, we could look at this as little problems. Well, what's 3 divided by 3? 3 divided by 3 is 1. So if we have the same thing on the top and the bottom, they cancel each other out. Right? Same thing with x. X divided by x, it doesn't matter what they are. If they're the same on the top and the bottom, we can cross them out. Right? So this problem gets a little bit simpler pretty quick, right? If I cross out the 4x's on top, the 4x's on the bottom, really all I have left in the end is I have 3 x's up top and I have a 3 in the bottom. So this final answer is x to the 3rd divided by 3. Now we need to deal with kind of a little more complex ones. So what if I did something like this? I have x to the 4th y, 3y to the 7th. And I'm going to raise that all to the 3rd power. So at first it looks like it's going to be far more complex, but really our same ideas hold true. What you can kind of do is just take out this middle part, right, and just say, okay, if I was to simplify everything in the middle, what would it look like? Well, that would be x to the 4th, y, 3y to the 7th. Now I could go through here and write x to the 4th is 4 x's, y to the 7th is 7 y's, 4, 5, 6, 7. Okay. But sooner or later it's going to be kind of easier to say, well, if I've got 1 y up top and 7 y's on the bottom, who wins that tug of war? Well, the bottom, right? The denominator. And it wins by how many? 6. Well, if you write it out, you can kind of get that same thing where y cancels out here and here. So you can have 6 y's on the bottom, 4 x's on the top, and a 3. So this thing, it doesn't simplify much, but it's going to make our life easier. This thing is really just the same thing as x to the 4th over 3y to the 6th. So that kind of idea that you can simplify whatever's in the middle before you do this to the 3rd power thing is going to be really nice. So to the 3rd power, anything to the 3rd power just means we're going to write this thing 3 times, right? So this is just x to the 4th times 3y to the 6th. X to the 4th, 3y to the 6th. X to the 4th, 3y to the 6th. Okay. So now what I want to do is I want to combine this thing. So when you're multiplying these together, these 3 expressions together, what you have to look at, right? I'm actually going to do it this way, kind of a little unconventional because I don't have any room on there. Well, how many x to the 4th do I have up on top? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I mean, I could write out 4x's, 4x's, 4x's and count them out like that. But I can just count them when they're in this form. Basically, I'm just adding the exponents together. So up top, I've got 12 x's. On the bottom here, I've got 3 times 3 times 3. Well, 3 times 3 is 9. Times 3 again is 27. And I've got 6, 12, 18. So I'm just adding 6 plus 6 plus 6 of them. So I got y to the 18th. And that's how you do it if you got something up like that. So a more complex example would be something like this. If you had x squared, and these problems can look really intimidating when you do them, but they're only as intimidating as you let them become, right? So this looks really bad, right? But I'm just going to break it up and see what I can do. So I know anytime that I have this thing squared, all that means is that I'm going to be multiplying it by itself, right? So this will just turn into x squared y times x squared y. This is to the third, no big deal. All that means is I'm just going to take this thing and multiply it by itself 3 times. And this is to the fifth, no big deal. I'm just going to write that out 5 times. Okay. So now what I want to do is I want to combine everything I combined. So really what this becomes is how many x's do I have up on top? Well, I have 1, 2, 3, 4. So I have 4 x's, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have 13 x's up top. Just count them up, and I have 1, 2, 3, 4, 5 y's. Down below I have 1, 2, 3, 4, 5 x's, and I have 5 y's. Now, I have 5 y's up top, 5 y's on bottom. That all 5 of those y's are going to cancel out, right? Like if I was to write out y times y times y times y, they would all cancel out. I'm just going to save myself the effort though, and then just cancel them out with that dust. So x to the 13th over x to the 5th, that's 13 x's like this, you know, and 5 y's on the top. So when I cancel out those 5 y's, the question is how many remain up top? Well, 13 minus 5 is 8. So this final answer is x to the 8th. A really common, and so that entire problem just boiled down to this, right? Far more simple. A really common mistake and something to watch out for is watch out for this situation if you have x to the 4th over x to the 6th. Well, I know that x to the 4th is 4 x's. I know x to the 6th is 6 x's, right? So if I was to simplify this, I have 2 x's left on the bottom. Well, we don't want to say, like, that's x squared, right? A really common mistake is people say, well, all that's left is x squared, so the answer is x squared. But these 2 x's live in the basement, right? They're in the denominator, right? And so they need to stay there. So the question is, what's on top? Well, a lot of people think that it would be 0 because there's nothing left up top, but we're talking about nothing in terms of multiplication. And 1 times anything is just itself, right? So I can put as many times 1's up here as I want, right? In this case, I only need 1, right? Because that'll kind of showcase the point. That's really just a 1 up there, right? So just be really careful about that, and you should do fine.